Everyone, welcome to my YouTube channel. Today we will solve the second problem. So let's quickly see the problem statement. So the problem statement is, given a number n, we have to calculate the square root of a number, right? So let's take an example. Let's say if the number n is 18, then square root of 18 is something 4.xyz, but we have to only return the integer number, so it is 4. Let's say if the n value is 36, so square root of 36 is 6, right? Let's take another example. Let's say the n value is 50, then square root of 50 is 7 point something ... So approximately we have to return the index, so the value is, so we have to return 7, right? So what can be the brute force approach to solve this problem? So the brute force approach to solve this problem is, we will iterate. Let's say the n value is 40, right? Then we will iterate starting from 1. We will check whether 1 into 1 is less than equal to 40. Yes, 1 plus 1 is less than equal to 40. Then we will update I value. I will be 2. Again we will do I. 2 into 2 is less than equal to 40. 2 into 2 is 4. 4 is less than equal to 40. Yes, then we will update I. Now I is 3. 3 into 3 is less than equal to 40. 3 into 3 is 9. 9 is less than equal to 40. The condition is satisfied. We will update I. 4. 4 into 4 is less than equal to 40. Yes, 4 into 4 is 16, is less than equal to 40. We will update I. 5 into 5. 5 into 5 is 25, is less than equal to 40. This condition is satisfied. Then we will update I. 6. Now 6 is to 6. 6 into 6 is 36. 36 is less than equal to 40. Then we will update I value. 7. Now 7 into 7 is less than equal to 40. Now 7 into 7 is 49. 49 is not less than equal to 40. The condition is not satisfied. Then we will simply return answer will be I minus 1. So I was 7. 7 minus 1. Then the answer is 6, right? So what can be the, so how many number of iteration we have reached? So the number of iteration is square root of n, right? Because here the n value was 40, so square root of 40 is approximately 6, right? Square root of 40 is approximately 6. So what can be the time complexity? So the time complexity of the brute force approach is order of root n, and space complexity is order of 1, right? Because we are using constant space. So this is the solution for the brute force approach. This is the time complexity for the solution of brute force approach. Now quickly move towards the optimized approach. Let's see the optimized approach. Before going to the optimized approach, let's write the pseudocode of this brute force approach, which is very simple. You can easily write, right? We will initialize I is equal to 1. Then we will check the condition while I into I is less than equal to n. If is I is equal to I is less than equal to n, we will update I, and then when finally we will return I minus 1, right? So this is a simple code for the brute force approach, right? Now let's see the optimized approach. So what can be the optimized approach? So let's see some observation. Let's say the n value is 50. Now what can be the lowest possible answer? Lowest possible answer can be 1, right? Because every number is divisible by 1, right? And what can be the highest possible answer? It can be n itself, right? For any given n. For any given n. Why not n by 2? Why not n by 2? Because let's take the edge case. Let's say the value of n is 1. So the lowest will be 1, highest will be n, which is nothing but 1. But if we take highest as half, then it will be 0, so it is wrong, right? So that's why the highest possible value is n and not n by 2, right, because of this edge case, right. So this is the edge case, so we have to handle edge case very properly, right. Now let's do some iteration. Now let's take low, high, middle element, condition, and action to be taken. Okay, now here low value was 1, highest value was 50, for the n value 50, right, because we are solving for 50, so highest is 50. So what can be the middle element? Middle element is middle element 25, right, 25 is the middle between low and high. Now the condition is 25 into 25. Now 25 into 25 is greater than n, because n value was 50, it is much more greater than n, right. So in that case what we will do, because it is much greater than n, so it cannot, the number cannot lie on the right side. So what we will do, we will simply discard right region. So what is the meaning discarding right region? That we will move towards left side, we will move towards the number which is less than 25, move towards left side, right. So we will update our high pointer will be mid minus 1, here the mid is 25 minus 1, so this is the updated value of highest. So lowest is 1, 24, what is the middle, will be 12. Now 12 into 12 is also greater than n, because 12 into 12 is approximately 144, I guess, yes, that is greater than n. So similarly we will, what will do, we will move towards left side again, we will update highest pointer as mid minus 1, which is nothing but 12 minus 1, which is nothing but 11. So lowest is 1, highest is 11. So what will be the mid, will be 6. Now 6 into 6 is 36. Now this 36 is less than n, because the n value is 50. So now this 36 is less than n, right. Now this is the special condition here, because till now we got greater than element. Now this can be one of the potential answer, right, but we don't know whether it is. We will go ahead, we will, what will do, but we will move towards better answer, right, we'll move towards better answer, we will go ahead. So what we'll do, we will store, first thing what we will do, we will store our potential answer into a variable. So what we'll do, we will store that answer into a variable called answer, right, we will store answer as mid, because middle is the element where the answer is stored. Now we will move towards better answer, so we will update low pointer will be mid plus 1. So mid value is 6 plus 1 is nothing but 7. So now the updated low is 7, high is 11, so it is 9, middle element is 9. Now 9 into 9 is nothing but 81. Now 81 is greater than n, so what we'll do, we'll move towards left side, move left side, we will update high pointer will be mid minus 1, so 11 minus 1, which is nothing but 10. Sorry, mid is not 11, mid is not 11 here, mid is 9, so 9 minus 1 is nothing but 8, so this is the updated answer. Low is 7, high is 8. So what will be the middle element? Middle element will be 7. Now 7 into 7, now 7 into 7, 49. 49 is less than 50, right, because n is 50, right. So this can be another potential answer, right, but still we will move but still we will move towards better answer. But we will update our answer to mid, and then we will update our low pointer to mid plus 1. Now mid is 8, mid is 7, right? Mid is not 8, mid is 7. So what we will do, we will update mid plus 1, which is nothing but 8. Now low, now let me draw this line. Mid, now the low is 8, high is 8, mid is 8. Now 8 into 8, 64 is greater than n. What we will do, we will move towards left, move left side. We will update high to mid minus 1. Mid is 8, 8 minus 1 is nothing but 7. Now low is 8, high is 7. Now this is the time where our loop ends, right? So we'll stop the iteration, right? We'll stop the iteration. Now let's quickly write the pseudocode. Let's quickly write the pseudocode from the given iteration. So we have to find square root integer n. We will initialize our low pointer to 1, high pointer to n. We'll take one variable where we store the answer. Let's say the answer is 1, while low pointer is less than equal to high pointer. Then in that case, first we will initialize our middle. Middle is nothing but low plus high by 2, right? Now what we'll do, we will check if mid into mid is equal to n. Then what we'll do, we will update answer to mid, and we will simply break because we got our desired answer. Else if mid into mid is less than n, then in that case what we will do, in that case we will simply move right side, right? We will update our answer, we will store our answer in answer variable, and we will update low to mid plus 1, right? Else what will be the condition? Else if mid into mid is greater than n, in that case what we'll do, we will move left side, because right section cannot be our potential answer, and we will update our high pointer. High pointer will be mid minus 1, right? And the loop is ended. Finally we will return answer variable, right? So this is the pseudocode of the approach. This is the pseudocode of the approach, right? So now what is the time complexity of this approach? So what can be the time complexity for this approach? So the low value is 1, high value is n. So what is the search space here? The search space is, initially it was n, then it reduces to n by 2, then it reduces to n by 4, and so on, right? So you can see each time we are reducing the search space by half. So what is the time complexity? Time complexity is order of log n to the base 2. And what is the space complexity? We are not using any space, so space complexity is order of 1, right? So this is the optimized approach. Now the brute force approach was taking the time complexity of order of root n, and the optimized approach is taking time complexity of order of log n. So which is better? So let's see by taking an example which is better. So let's see, brute force time complexity was order of root n, and optimized approach time complexity was log n to the base 2, right? So let's say the value of n is highest value, 10 power 9. So it will be square root of 10 power 9 and log 10 power 9 to the base 2. Now we know that 10 power 9 is approximately equal to 2 power 32, right? But here 10 power 9 is nothing but 10 power 4 into square root of 10, and here we will update 2 power 32 or 2. We know this condition, right? This will go here, it will be 32 log 2 to the base 2, and this log to the base 2 is nothing but 32, right? So 32 number of iterations is required here, whereas here we need this root n is nothing but 3 a time, right? It is nothing but 3. So let's say it is approximately 30,000 iterations are required. So root n is taking 30,000 iteration and optimized approach is only taking 32 iterations. So this is much more greater than the number of iterations required here is much more less compared to the brute force approach. So that's why the optimized approach is much more efficient solution. Okay, thank you.